Okay, you guys, in this section we're talking about vectors, the goals. Number one, we want to add, subtract, and what we call scalar multiply vectors. Number two, we want to write vectors in component form and ij form. Usually I use a little arrow notation over the I and j. And goal number three is to solve applications. I'm going to draw some arrows for you. These arrows ultimately are how we can represent vectors. What do these vectors have in common? Yeah, that's true. They are all parallel. Good observations. How did I draw? Okay, let's call this. So these are arrows, right? They're called vectors, but if you think of them as arrows for now, let's call, just to pick one that's fairly straight, let's pick this one. And let's call this point here the tail of the vector, of the arrow. And let's call the point with the arrow on it the tip. What did I do in each of those arrows to get from the tail to the tip? Okay, or right 2 over 3, either way, right? Oh, yeah. Right 2 up 3 is what I should have said. So, and that's true no matter which one you look at, no matter which tail and no matter which tip you look at, to get from the tail to the tip, you go right 2 and up 3. So in a very real sense, you guys, these vectors, we don't want to call them equal because they're not, right? It would be like saying 2 congruent triangles are equal. 2 congruent triangles are not equal. They're different triangles, but congruent means that they're equivalent. The corresponding pieces are the same length or same angle measure. So likewise here, we want to say these vectors, these arrows are equivalent, okay? I suppose congruent would work, but we don't usually use that unless we're talking about triangles. So in a very real sense, they are congruent. And in I mean, obviously they're not the same. They're all different. But in a very real sense, they're equivalent because to draw them starting from tail and going to tip, you do the same thing, right? So how could we invent some sort of notation to indicate the one kind of vector that all of these green vectors represent? What could we do?
Put them, like coordinates?
Yes. But the coordinates would actually be the change in the horizontal value for one coordinate, and then the other coordinate would be the change in the vertical value. Right. And one way we represent the change in the horizontal, so if we draw, picking on this vector, if we draw in this right triangle here, then we often represent the change in the horizontal as delta x. The Greek symbol delta looks like a little triangle, x. We think of that as one quantity. And delta x means change in x, or change in the horizontal. And then that's for the horizontal side. And then the vertical side we would call delta y, which means change in y. So the way you're used to thinking of slope, you would say slope is delta y over delta x. That's not quite how we're going to do that here. We're going to represent these vectors as coordinates. But instead of using regular parentheses, we're going to use alligator brackets. The first coordinate we would call delta x. The second coordinate we would call delta y. And this would be a way to represent what we call the component form. So let me tell you what this notation is called. This notation is called the component form of, I do use the word the vector, represented by all these pictures. Okay, so in a very real sense, all these pictures represent the same vector, at least in component form. Okay, now this is not an ordered pair that you necessarily, it doesn't represent a point that you're used to, right? However, if you plot one vector in particular where the initial point, the tail is 0, 0, then it does turn out that the tip will be delta x, delta y. In fact, in this case, what is delta x, delta y? In this case, how do we represent the vector? Delta x is equal to what? In this case, 2, and delta y is equal to 3. So in this case, delta x is 2, delta y is 3. So we would represent the vector as the, well, ordered pair 2, 3. What is the mathematical definition of a vector then? Well, it is an arrow. It's just what we said it is. But I guess we would call that a directed line segment in math.